Good evening.
Good evening, sir.
Good evening, sir. Good evening.
Good evening, sir.
Then I think last week we had a discussion about discrete probability distribution. I think we discussed binomial distribution, no? Who can remember the last things we discussed? Did you discuss this part, binomial distribution?
So we have to start from this slide, I think.
Yes, I also think so. Okay, then in the previous session, we had a discussion about discrete random variable, where we learn how to construct probability distribution for discrete random variable. Then today, our discussion is about binomial distribution. This is a mathematical model which we can use to calculate probability related to discrete random variable. Let's say, as example, let's say you apply for 10 jobs. Let's say you apply for 10 jobs. Then probability of call for interview is, let's say, 0.3. That means you have applied for 10 jobs. Then we know they are shortlist your application and call for the interview. Then we assume probability of calling for interview is 0.3. Then our random variable x is, let's say, x0. 0 mean you have applied for 10 jobs, but they did not call for interview from any jobs. Let's say 1. 1 mean they call only one interview. 2 up to 10. Then if the probability of calling interview is 0.3, you can see what is the probability that you will call 2 interviews, maybe 3 interviews, 4 interviews, like this. Okay. These type of probabilities you can calculate using binomial distribution. Then another one we have Poisson. Then later we will discuss this. Today discussion is about binomial distribution. Then first you should know the properties of binomial distribution. These are the essential properties of binomial distribution. The first one is a fixed number of observations. That means if you want to apply binomial distribution, there should be fixed number of observations. As example, 15 tosses of a coin. You toss coin 15 times, then n equal 10. 10 light bulbs taken from a warehouse, then n is equal to 10. Let's say these bulbs you can divide into two. Let's say defective bulb and non-defective bulb. Let's say if the probability is 0.8 for non-defective bulb, then you can calculate probability. What is the probability that if there are 10 bulbs, what is the probability that if you buy 2 bulbs, what is the probability that both 2 bulbs are non-defective? Then another property is each observation is categorized as whether or not event of interest occur. That means now if you toss a coin, you can get head or tail. That means each observation we can categorize into two, head or tail. The event of interest means, let's say your interest is to see the head, then head and tail. Head is the event of interest. Then we can say these two categories are mutually exclusive and collectively exhaustive. Mutually exclusive means if you toss a coin, you will get head or tail. You can't get both head and tail simultaneously. It is we call mutually exclusive. That means if you received head, then the same time you can't see the tail. If you receive tail, same time you can't see the head. This is we call mutually exclusive. Then the collectively exhaustive means, then if you toss a coin, the two outcomes are head or tail. Then there is no any possibility to receive any other outcome. Okay. That means if you toss a coin, definitely you will receive head or tail. The collectively exhaustive means there is no any chance or any probability to have any other outcome. You can receive either head or tail. And mutually exclusive means both head and tail can't occur simultaneously. Then since these two categories are mutually exclusive and collectively exhaustive, then if the event of interest occur is phi, then 1 minus phi is the interest of not occurring. Okay, then the third property is that one. Constant probability for the event of interest occurring for each observation. That means if you toss a coin 10 times, 10 times, then each time the probability you receive head or tail is 0.5. Okay, 0.5. Then the observations are independent. The outcome of one observation does not affect outcome of others. That means each observations are independent. Okay, then these are the examples for binomial distributions. Okay, then here I'm going to explain how we can construct or how we can derive binomial equation. That means now this is the
Doctor, we still see the previous slide.
now is it moving or
No.
now?
Yes, now it's
Okay, then this is we call binomial formula. Then now I'm going to explain how we can derive this equation. Okay. Okay, then the last week also we did a similar type of exercise. Then let's say you toss a coin 3 times. You toss a coin 3 times. In how many ways can you get 2 heads? This is very simple. We realize that there are 3 ways to get 2 heads. Now, with the T diagram, you can see it. There are 3 ways to get 2 heads. But if I ask for, let's say, if you toss a coin, let's say 10 times, the situation may be little complicated. If you toss a coin 5 times, what's the probability that you're getting exactly 3 heads in 5 tosses? Then you can do this exercise, then you can realize it. Okay. Then now we toss a coin 5 times. How many ways we have getting 3 heads? 3 heads. Then how to identify? Then the one method is you can draw a T diagram. Then this is the first coin, second, third, fourth, fifth. Okay, then you can take a piece of paper and draw a T diagram, and you can identify how many ways we have getting 3 heads if you toss a coin 5 times, or if you toss a 5 coins. That means head, 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 tail, tail. Then sometime tail, head, 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 tail. Like this, there are many ways you can get 3 heads and 2 tails. Then now you can do this exercise quickly. Then take a photo and send your answer into chat box. Are you ready to do this exercise? Are you ready, or should I?
Yes, sir. Yes, sir.
Okay. Then I'll give maybe 5 minutes. Yes. Then I can see few answers in the chat box. One say 8 times, one say 10 times. Then one way to get 3 head is head, head, tail, tail. Then the probability is probability of getting head, 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 tail, tail. Then in each time it is 0.5. Then the probability is equal 1 over 2 to the power of 3 into 1 over 2 to the power of 2. Then another way to get 3 head is tail, tail, head, head, tail. Then the probability is same as previous one. Probability is same as previous one. Then like this, how many ways we have get 3 heads? There are 10 ways. There are 10 ways to get 3 heads. First one, let's say tail, head, head, tail. And like this, there are 10 ways. Then the probability is equal. The probability related to one outcome multiplied by 10. Why we multiplied by 10? There are 10 arrangements. That means 10 outcomes. Each outcome, the probability is same. Then we multiplied by 10. Then in this example, actually the difficult part is to identify number of arrangements. Number of arrangements. Number of arrangements. To identify number of arrangements. Then we have simple way or another mathematical equation to identify number of arrangements. Then this is the formula. you can use to identify number of combinations or number of arrangements. We call it is NCX. Then this symbol stands for factorial. This stands for factorial. Factorial means, let's say n factorial is equal n minus 1, n minus 2 up to 1. Let's say as an example, if you take 5 factorial, this is equal 5 into 4 into 3 into 2 into 1. Let's say x is equal to 3, then 3 factorial. It is equal 3 into 2 into 1. Then by definition, the 0 factorial is equal to 1. Then in our example, we toss a coin 5 times. Then n is equal to 5. Then x is equal to 3. That means 3 heads. We want to get 3 heads. Then now you can insert given information here. N 5 x3 equal 5 factorial 3 factorial 5 minus 3 factorial. Then you can take the answer. Then the 5 factorial means 5, 4, 3, 2, 1. Then 3 factorial means then here 2 factorial. Then you can then the answer is 20. That means 4 into 5, 20, 20 over 2. There are 10 arranged. Then no need to draw a T diagram. Then you can get the answer quickly. Let's say same example, you toss a coin 5 times. Then how many ways you have get, let's say, 2 heads? How many ways you have get 2 heads? Please do this exercise. N is equal to 5. Now x is equal to 2. You toss a coin 5 times. Then you want to see 2 heads. How many ways you have getting 2 heads? Then using this formula, you can get the answer. Please send your answer into chat box quickly. 1 say 10. Let's see. Then n is 5. X is 2. Then this one you can write 4, 5 into 4 into 3 factorial. Then 2 into 1 into 3 factorial. Then these two you can cancel. Then answer is 10. Okay. I hope you got the point. Okay. And now you can see the formula. In this formula, now this part, I explain how we can get this part. Okay. N factorial, x factorial, n minus 6. Then what is this one? This is the probability of event of interest occur. If you toss a coin, the probability is 0.5. Okay. Then here 1 minus this probability. Then x is number of event of interest in the sample. N is sample size. Okay, then quickly you can do this exercise. Flip a coin 4 times. X is the number of heads. Then what is the probability that x equal, let's say 0, x equal 1, x equal 2, 3, 4. Then you have to insert your information here. Then you can see another example here. What is the probability that one success in 5 observation if probability of an event of interest is 0.1? Now let's say as an example, you visited, let's say GN office. GN office means Gramanilladari office. GN office. To meet GN or Gramanilladari. You have visited 5 days to meet GN. The probability that GN is at his office is 0.1 because he is going throughout his area. Then he is not available at the office every time, then let's assume probability is 0.1. Then if you visit 5 times, what is the probability that you meet GN at one time? As probability is 0.1, if you visit 5 times, sometime you may meet 1 time, 2 times, 3 times, 4 times, or maybe 5 times, maybe 0 times. That means you went there 5 times, but you did not meet. Then this is the way to get the answer. 5, 1, 5 minus 1, the answer is this. Please check whether you can get the same answer. See this example. Suppose the probability of purchasing a defective computer is 0.02. What is the probability of purchasing 2 defective computers in a group of 10 computers? That means there are 10 computers. You will buy 2 computers. Then according to, let's say, manufacturer, 2% are defective. Then what is the probability purchasing 2 defective computers? Then n is 10, x is equal to 2, probability 0.2. Then answer is this. Check whether you can get the same answer. Okay, then actually to calculate the probability, sometimes you have to do some calculation. Now I'm going to explain one method to get the probability without doing calculation. That means it is through the binomial table. You can use binomial table. Then I can share the binomial table with you. Then I have shared 2 documents, binomial table and Excel file. Please check whether you can open it.
I couldn't find the Excel file. Binomial table, of course, downloaded.
Excel file, yes, give me 1 second. Okay, in our previous example, n is equal 5, n equal 5, then the x equal 1. And the probability is 0.01. Now this is we call binomial distribution or binomial table. Then using this table, you can calculate probability easily. No any calculation. Okay, then this table shows probability of X success in an independent trial, each with probability of success P. Then here P is the probability of success. That means in our example, P is 0.1. P is 0.1. Then how many trials we have? 5 trials. 5 trials. Okay, 5 trials. Then the possible value for X, 0 up to 5. Then the probability you can find from here, 0.1. Then no, so probability is 10%. Then these are the probabilities. What is the probability that X equal 1? It is 3.28. X equal 2, it is 0.73. X equal 0, it is 5.9. Now with this table, you can easily calculate probabilities. Shall I explain again it? Now let's say n is equal to 5. P is equal 0.1. You visited GN office 5 times to meet GN officer. The probability that GN officer is available at the office is 0.1. What is the probability that you did not meet GN officer? What is the probability that you meet 1 time, 2 times, 3 times, 4 times, 5 times? Then first you have to find P here. then n, then the x, then the probabilities are 0. I hope you got the point. Let's say another example. You toss a coin 5 times. You toss a coin 5 times. P is 0.5. What is the probability that you get 0 head, 1 head, 2 head, 3 head, 4 head, and 5 heads? Where is the answer? Then the probability is here. Then n is 5, x is here. Then the probabilities are you can see here. Then another example. Let's say n equal 5. Let's say p equal 0.9. P equal 0.9. Okay. 0.9. Then what is the probability? Then the probabilities are 0. Then now I'm going to give a small activity for you. Now here you can see 3 scenarios. In the scenario 1, probability of success is 0.5. The second one, probability of success is 0.1. Then the third one, probability of success is 0.9. Then now you can sketch the probability distribution. You can sketch the probability distribution. I will show the first one. Let's say x, px. X is, let's say, 0, 1, 2, 3, up to 5. Then you can see the probability here. First one, 0. Probability is, let's say, this much. Then x equal 1. Probability is like this. X equal 2. Then the probability curve goes like this. If the curve is like this, we call it is right skewed distribution. Right skewed distribution. Now you can see if the event of interest occur is less than 0.5, the probability distribution is right skewed one. Then we have another 2 scenarios. Then you can sketch these 2 probability distribution and take a photo, and you can send your answer into chat box. Then only you can realize how shape of the probability distribution change with the change of probability. Shall we do this exercise? Yes. Are you doing this exercise?
Yes, sir.
Okay. Please send your answer into chat box. Then what is the shape of distribution related to this one? It is a symmetrical distribution. For this one, the distribution is left skewed. It is like this. You can see one answer in chat box. I hope you can see it. Can you see it? Yes, he has draw a curve or draw probability distribution using Excel. Then you can see first one is symmetrical, the other one is left skewed. Okay, then we will move to another way to find probability. It is we call Excel. That means through the Excel also you can find the probabilities. Can you see this Excel screen? Hello.
Yes, sir.
Okay. Then let's say n equal 5. Probability of success is 0.1. Then x is 0, 1, 2, 3, 4. Then you can find the probability using this. Let's say you have sample size is 5, probability of success is 0.1. Now I am going to explain how we can get the probability through the Excel. Then here x is 0, 1, 2, 3, 4, 5. Then you can type here binomial. Then you can see the binomial distribution. Then the numbers mean this x. Then the trial means sample size, comma. Then the probability, comma. Then you have two options, cumulative distribution or probability mass function. Then close the bracket. Okay, I will show it again. Equal binomial. Then the numbers mean x, comma. trial 5, comma, then the probability, comma. Then we have two options, cumulative distribution and probability mass function. We select probability mass function. Then close the bracket. Then you can see the probability. Then you can click and drag to calculate probability related to other values. But before that, you have to make some changes because here 5 is constant value, probability also constant, then you have to convert these values into constant. Then the B13 mean this value, it should be changed. Then the B4, when you type $mark, between these values, then you can convert it into pixel. Then now you can click and drag. Then you can see the probabilities. Now you can plot this one. Now you can see the probability. It is a left skewed distribution. Now let's assume probability is 0.5. Then you can see the distribution become symmetrical. If the probability is 0.9, then you can see the distribution become left skewed. Okay, then what is the actually cumulative distribution? Now again, I type here binomial numbers, comma, trial, comma, probability, comma, then select probability cumulative function. Then again you make these two values constant values. Then you can click and drag. So now you can understand what is the difference between cumulative probability. Cumulative probability and the probability. Now here you can see this value is equal this plus this one. Or else there is a technical error. Okay, however, this value shows actually P is x equal 1 no less than 1. X equal 1 no less than 1. The cumulative probabilities. My computer was stuck, I think. Okay, then this is the way to find probability using Microsoft Excel. Okay, then there is a technical error. Now it's work, I think. Okay. Okay, then if you have still not received LMS access, please send an email to me, MFE at icon.cmb.ac.lk email address. Then
Can you tell me the email again? Sorry.
yes, it is MFE at icon.cmb.ac.lk. Send your name, email address is there, then the course, let's say MFE 23 semester 1. Okay, then I hope you got the point here. Okay, then we will move to again our PowerPoint presentation. Shape of the binomial distribution already we discussed. Shape of the binomial distribution depend on the value of probability of success and n. Mainly actually probability of success. It depends on probability of success. If n equal 5 and probability of success is 0.1, the shape is like this. If it is 0.5, the shape is symmetrical. If this is 0.9, the distribution is like this. Then we have another few concepts. The first one is we call mean of probability discrete probability distribution. Expected value. It is equal n into 5. Then the variance is equal n into 5 into 1 minus 5. Then the standard deviation is square root of this. Then you can see here mu or expected value n equal 5, probability of success 1, the expected value is 0.5. Then the standard deviation is 0.6708. Then n is 5, probability of success is 0.5. Then expected value is 2.5. Then the standard deviation is 1.18. Okay, this is the end of discussion related to binomial distribution. If you have any question related to binomial distribution, now you can raise. Okay, then our next topic is Poisson distribution. We will discuss it in next week. I hope you learned something from today's session. If you have any feedback, you are welcome.
Thank you, sir.